All right, so we're going to be doing an example where I'm going to be building a tree diagram. And the prompt is, the holiday season is rough on airports of all flights. And there is a 30% chance of one of those flights being delayed. If a flight is delayed, there is a 65% chance of it being canceled. However, the non-delayed flights only have a 5% chance of being canceled. And then they've provided some questions for finding those probabilities. So let's start out by making a diagram. I know that a tree diagram will probably be most useful because of the concept of the if-then statements. In order for one thing to happen, then the next thing will happen, and so forth. So the first thing I'm going to look at is that second sentence. Of all flights, there is a 30% chance of one of them being delayed. So I'm going to focus on the context of the problem, and I'm going to start with flights. And I'm going to consider this all flights. So of all flights, they are either going to be delayed or not delayed, because that is the first thing that they're talking about here for all of the flights. Then it becomes the conditional statement, or the if statement. If a flight is delayed, that tells me that I'm going to be working down this branch of the tree. If a flight is delayed, there's a 65% chance of it being canceled. So for delayed flights, I'm either going to be canceled or not canceled, which is also known as the complement. For the non-delayed flights, so this means that of the flights, I'm going to be moving down this part of the tree here for non-delayed, then I only have a 5% chance of being canceled. So here my options are canceled and not canceled. Now that I have the context of the problem on my tree, I'm going to go back and fill in those probabilities. So for flights being delayed, I have a 30% chance, and I'm going to write that as a decimal of 0.30. Now something to keep in mind, when you have a tree branch set up, your branches of the same level should equal up to 100% or a 1.0 probability. So 100% minus 30% is 70%. And I'm going to label it as a 0.70 for non-delayed flights. I'm going to go ahead and change my color because now I'm going to be looking at the condition that a flight has been delayed. Of all the flights being delayed, a 65% chance of it being canceled. 65% chance of a delayed flight being canceled. Again, branches of the same level should equal up to 100%. 100% minus 65% gives me a 35%, which I'm going to write as a 0.35. And then my other condition is that it is not delayed. So of all the flights that are not delayed, there is a 5% chance of one of these non-delayed flights being canceled. 5% is a 0.5. Common mistake for students here. 100% minus 5% gives me a 95. Again, my branches of the same level should add up to 100% or a 1.0 probability. That is why I also color-coded those individual branch levels. So that way my purples add up to 100%, my reds will add up to 100%, and my greens should add up to 100%. So let's talk about the very first question. Find the probability of a flight not being delayed and canceled. So I'm just going to point out here that this and is one of my probability rules. So I'm going to write this out. The probability of a flight not being delayed, so not delayed, and canceled. Now I'm just also going to point out another way you could see this is using the notation not delayed and canceled. Both notations are exactly the same. And if I were to do this, that means I want multiplication. And means the multiplication property. So we're going to look for the probability of not being delayed. So we're going to be working our way down the branch. Not delayed is a 0.70. and gives me that multiplication, canceled, not delayed. And now that I'm in that not delayed, the probability of those being canceled is 0.05. So if I were to multiply this by 0.05, this is going to be giving me a 0.035. And that is the probability of not being delayed and canceled. If I were to rewrite this as a percentage, it would be 3.5%. All right. The second part is saying find the probability of any flight being canceled. So let's take a look at that tree up here and notice there are actually 2 times where a flight can be canceled. A flight can be canceled if it's delayed, and a flight can be canceled if it's not delayed. So we need to look at both of these concepts and we have to put them together. So let's do that. We're going to look at the probability of it being canceled and delayed and canceled, plus, because remember it happens in 2 different incidences, canceled and not delayed. The probability of not delayed and canceled. This is also known as my OR. So I can be canceled from a delay, or I can be canceled from not being delayed. And we're going to look at putting both of these together. Again, multiplication is our and. So we're going to make this multiplication here. Boom. So let's start filling in these numbers. Delayed and canceled becomes a multiplication. So a delayed flight happens 0.3% of the time. Coming up here, delayed happens 0.3% of the time. Canceled from there is 0.65. Or we can have a canceled flight from no delay and cancellation, this being a 0.7 and a 0.05. Plugging these into my calculator, I would be getting the following: a 0.195 plus a 0.035, which is going to be equal to a 0.23, or also known as 23%. So that's how I would find the probability of any cancellation. I have to consider cancellation when it's delayed, as well as cancellation when it's not delayed, and putting those 2 together to find all cancellations. All canceled flights. All right. My next one, topic C, is find the probability of a flight being delayed given it was canceled. So this given is a condition. So let's look at what that means. The probability of a flight being delayed given it was canceled. Again, other notation that you can be seeing for this: probability, delayed, given, cancellation. So something to keep in mind, you can see it as a vertical line, or you can actually write out that word. So let's fill in what we know about a given probability. This means that I have to consider the and over the condition. Both of them happening at the same time over that condition that they gave me. The and is the probability of it being delayed and canceled all over what the condition was. The condition was that it was given that it was canceled. Canceled is my condition. So I'm going to put the probability of canceled on the bottom. Well, the great thing about these 2 items, both the numerator and the denominator, is we've found those numbers before. So the probability of being delayed and canceled is looking at this and going delayed and canceled. 0.3 times 0.65. Well, we've done that already here. 0.3 times 0.65, and we got 0.195. All over the probability of any flight has been canceled. Well, we've looked at this before. In fact, that was actually question letter B. What's the probability of any flight being canceled? Well, we found that already, and we got 0.23. So we're going to add that to the bottom, 0.23. If I take 0.195 and divide it by 0.23, that's going to give me 0.847, which is also approximately 85%. This is a very large percentage, so let's think about this. Of all the canceled flights, 85% of them are a delayed flight. Well, that seems to make sense because most of the canceled flights were already delayed. So this percentage makes sense for our problem. The last piece of this is going to be the independence. So let's look at part D. If a flight was canceled and delayed, are those independent? So we're going to look at cancellation and delays and see if they are independent. So what I'm going to do is the concept of independence means that if I do delayed and canceled, it should be equal to, but we're going to double check, the probability of any flight being delayed times the probability of all flights that have been canceled. And the great thing is that we have this information already, and we're just going to plug in what we know. Delayed and canceled, we're multiplying 0.3 and 0.65, which we already know is 0.3 and 0.65 here, which gives me 0.195. Keeping that question mark here, any flight being delayed is a 0.3. Any flight being canceled, so I'm just going to come on back and get over here. Any flight being canceled is 0.23. So I'm going to write that number down, 0.23. Well, the question is, are those going to be close enough for me to feel comfortable claiming it to be independent? Well, I see both of them have a 0.3, but one has a 0.65 and one has a 0.23. Those numbers seem a bit off, but we are going to just verify it. 0.3 and 0.23 gives me a 0.069. If I look at these numbers, 19% and 6% or even 7%, those are very far off. I would say those are not equal or not close enough, which means that being delayed and being canceled are not independent. And that's how we can use a tree diagram with decimals to answer those questions.